In the last chapter, we talked about phenomena around charges at rest. We basically studied charges at rest. Here, we are going to study charges in motion and the phenomena around it. That is called current electricity. Here, current means anything that is flowing. Current electricity means flowing charges. So that's what we call electric current. If water flows, we call it water current. If wind blows, we call it wind current. If charge flows, we call it electric current. So there must be a definition to measure something. So that is the essence of modern science. If you define something as a way to measure them, then that is a proper definition. So how are we going to define this flow of charges? So like you have the price of a gold per gram or anything for unit value, it is always easier to extend that concept. If there is 1 gram, so and so price, then for 10 grams, just multiply by that. In the same way, suppose if you take a conductor, because for the charges to flow, we need a special type of materials called conductors. Only in conductors, charges flow. There are 3 types of conductors, like it can be a solid, it can be a liquid, and it can also be a gas. So, though gases are poor conductors, we can facilitate the gas to conduct electricity. So, conductors in all 3 types. Okay. Suppose you take a conductor, and here I am having a solid conductor or anything liquid or gas, anything. And if the charges are flowing in this direction, you have to take a cross section perpendicular to the flow of charges, because it will be easier for us to measure the number of or count the number of people coming in the room at the door. When the people are coming in, the door is the cross section. In the same way, if the charges are going this way, and we need to take a cross section perpendicular to the flow of charges. So through this cross section, in 1 second, how much charge is flowing is called electric current. Point number 1. Suppose you are waiting for t seconds. In t seconds, if the total quantity of charge flowing through this cross section is q, then like 10 people got 20 chocolates, then for 1 person it is 20 by 10. In the same way, for t seconds you are having huge coulomb of charges flowing through the cross section. Then for 1 second, the amount of charges flowing will be q by t. This is called electric current. So the electric current is defined as the amount of charges flowing through a cross section. That cross section must be perpendicular to the flow of charges per unit time. Then how do we define this? So we know that it is charge by time, but that's not how we are going to define it. When you write current, it is charge by time. Suppose how we are going to do is, the current will be equal to charge when the denominator is 1. Because the denominator is time, we call it 1 second. 1 means 1 second here. So in 1 second, what amount of charge is flowing is called electric current. So electric current can be defined as the amount of charges flowing, because electric current is equal to amount of charges flowing, because here Q refers to amount of charges flowing. So electric current is defined as amount of charges flowing in 1 second. Or the other way of expressing this is, suppose initially within this there is a Q1 amount of charge. Then after some time you will find Q2 is the amount of charge. Then the amount of charge that crossed will be equal to Q2 minus Q1. So that is called, if delta Q is the amount of charge flowing in a time interval delta T. So there is no particular difference between T and delta T. because if you are using a stop clock, if you turn on the stop clock, initial time t1 is 0. If you turn it off, the final time shown is t. So the time interval will be t minus 0 becomes t. If you are having your watch and it is 6:30 and then after a while it is 6:35, then the time interval is 6:35 minus 6:30 is 5 minutes. So that's what the difference between t and delta t, but both are time intervals only. So I can be written as total amount of charge flowing per unit time, the same thing. This is the general way of writing it, but this is more proper way of writing it, okay, because we are not always starting from 0. Okay, if delta t is tending to 0, if delta t is tending to 0, this delta q becomes dq, very small amount, delta t becomes dt. So this is called average current. If this thing is not there, total charge flowing by total time taken, capital delta q by capital delta t is called average current. If delta t tends to 0, we call it instantaneous current. What is instantaneous current? You know that instantaneous current means the amount of current at a particular instant. At a particular instant means t becomes 0 at a particular instant. There is no time interval, but it is not like that. If delta t is very small, suppose the current is flowing for half an hour, the time interval of 2 seconds or 3 seconds is very small. That's what delta t tends to 0, but it is not 0. So when delta t tends to 0, this delta t becomes very small t. So we have to use small delta from Greek letter. So that is, we are writing it as dt. So dt. In dt time, 0.01 second, maybe 0.01 coulomb might be flowing. So 0.01 coulomb by 0.01 second becomes 1. So then there is a current of 1 ampere is flowing. So when dt becomes very small, dq will also become very small. So dq by dt will have a definite value. That's why when you want to write average current, so there are 3 ways of writing this. I will write that. In general, in 10th standard you would have written current as charge by time. This is the general notion. Little bit proper notion, current is equal to, or average current is equal to delta q divided by delta t. This is average current. What is instantaneous current? For instantaneous current we use the letter I. I is equal to, when delta t tends to 0, delta q by delta t is considered as instantaneous current. When delta t tends to 0, I becomes dq by dt. This is called instantaneous current. So there are 2 types of current we are going to deal with. One is average current, I mean the total charge flowing over a particular time, and instantaneous current, the current at a particular instant. At a particular instant means for a small duration of time there is a small amount of charge flowing. That small value by small value will have a definite value. For instance, I gave 0.01 coulomb flowing in 0.001 second means you will have 10 coulomb per second. So you will have a definite value. So this is what delta t tends to 0. So delta t tends to 0 means dt is going to be very small value. Okay, so now I'm going to talk about 2 things now. So you know that electric current is rate of flow of charges. Rate means for every 1 second. So I will recap. This is the most important thing. The flow of charges is defined as electric current. This is a qualitative definition. And rate of flow of charges is called electric current. It is a quantitative definition. Rate of flow of charges means rate of flow for every 1 second. The amount of charge flowing through a cross section perpendicular to the flow of charges is called electric current. There are 2 general ways of writing electric current. Average electric current, instantaneous electric current. Average electric current is total charge flowing per unit time, and instantaneous electric current is electric current at a particular instant. Here exactly not an instant, for a small interval of time, what small amount of charge is flowing, the ratio of which will give you a finite value. This dt cannot become infinity, there is 0, so that I cannot become infinity. When dt is very small, in that time interval dq will also become very small, so that the ratio is a finite value. Okay, now what is the unit of current? One is, the unit of current is called ampere. When you write it as, you have to write the full name AMPERE with the first letter small letter, and the unit of charge is coulomb, and unit of time is second. The unit of current is ampere. 1 ampere means 1 coulomb of charge flowing through a cross section in 1 second. That is called the definition of unit of current. The unit of current is ampere. What is the definition of unit of current? The definition of ampere. Definition of ampere means, what is 1 ampere? What is 1 ampere? If 1 coulomb of charge flowing through a cross section perpendicular to the flow of charges, then the current is said to be 1 ampere. The current is said to be 1 ampere if 1 coulomb of charges flowing through a cross section in 1 second. That is the definition of unit of current. That means the definition of ampere. And the charges flow only in conductors. There are conductors in all 3 states of matter: solid, liquid and gas. Of course, plasma is a good conductor. Then in solid, current is primarily because of electrons. Electrons meaning free electrons. In liquid, current is due to both positive and negative charges. This negative charges may be electrons or it might be ions. The positive charges may be protons or might be ions. In liquid, the current is due to both the motion of positive and negative charges. But in solid, the current is because of, especially in metals, the current is because of free electrons. We'll discuss about it in another session.